Today in this video I will be continuing on building out our renderer. Yeah, last time we started preloading some data into the renderer. When we create our application, we started moving out the non-renderer specific parts, meaning that in the end our renderer should only get data, and we want to decouple the resource creation inside the renderer from the actual world data of sorts. So whenever we create a world, we would like to just make sure that the renderer has the relevant data and yeah, is able to do the actual rendering of whatever objects we want to render. So we've started decoupling that. I realized off stream that we need to implement a custom move operator, since our D12 resources actually do internal mapping on calls to their internal to get their internal pointer in order to store data on them whenever the CPU has actual access to them. That means that whenever we create a vector of these kinds of objects, whenever the vector resizes, the objects are of course moved from one memory location to another, or in other ways just moved, because the vector has to resize, deallocate, and move the resources to another place in memory perhaps, and therefore each object actually gets destroyed, or rather moved, and we get a D12 error whenever a vector is resized, because we do not reset the internal pointer on a move. We do call release, but that happens after the move when the old object is destroyed, and since we have to manually reset this pointer on a move operation, we end up in a state where the old object does have a pointer internally, which means that this area does get called, but the pointer is sort of invalid for unmapping, since we moved the old object and no longer have a valid pointer here. So we could do just some checking if we actually are able to get a pointer here. That would probably be better, and we could do some insurance policy of sorts, where we set the null pointer to 0 on release, but we could also just implement a custom move. I think this is supposed to fix that. We can try not calling the reserve on this vector, since that will force a resize, as far as I know. Now we still have a problem with the move operation, as you can see here. It's because this is set and we might not ever have mapped uh, the actual resource. Let's see. Yeah, we might have mapped the old resource, or rather not have mapped the new resource. Maybe we need to transfer the actual pointer as well. So yeah, we need custom move operations. For now, we can solve it by just making sure the vector never resize, but eventually we will have to handle that case where it has to resize. So yeah, it's a bug that needs fixing and a custom move operator. Yeah, but that's not a high priority right now. We can fix it by just reserving, and we create the relevant buffers um, for our materials, for our meshes, whatever. And I would like actually to implement a box for each light. So yeah, we would like to automate this part of the algorithm eventually whenever we do more lights. Um, for now, it's just going to be hard coded that we have our, or rather, maybe I should just implement it. Yeah, maybe I should just implement it right away. So let's do a vector of lights. Do we just create light data? I think we do. Pass data is based on lights, which is just pure light data for now. So let's pass that in. Whenever we create our light data, yeah, then we can ask the application to iterate through all of our light in lights. Let's see, did we not implement that? No, we didn't. Let's see. Uh, and for each of those, uh, yeah, right now it only allows us to create one. Maybe we want an index instead. Let's see. Right now we will only support creating one, but eventually we will have to um, change this algorithm. We just move the vector inside the new vector structure, and we want the position to be, let's see, our lights position, is that the same type? Yeah, float 3. So let's see, an R value reference. Yeah, it's because yeah, we could do some overloading, but we will use yeah, that's a R value for now. This is just copied in, doesn't need to be passed by reference. Yeah. So for now, this should work exactly the same. Yeah, it does. So yeah, for each light, we create a box that surrounds it. We can always change the method in terms of whatever box we want to be created for our lights, and we also have to sort of handle it more dynamically whenever we get more lights, but right now it's not a priority to implement that. We have just a starting point to do that, since it's just vertices that we upload with specific colors, and then we just need to change the values. We should also do a check whether the lights actually has position data, because some lights will not have position data, only directional, and spotlights will have directional, or rather position data. So yeah, let's see, what do we actually initialize the position as. Yeah, we can't invalidate it, so maybe we should do some extreme value to check if it's invalidated or not, but yeah. Yeah, maybe we just check if the the lights is positioned at the origin of the world space, and it's highly unlikely that we would like to position a lights at the origin. Anyway, yeah, I don't know. We would need to make some comments at least to handle that situation. So yeah. Um, so right now we have pre-allocation of different resources. We have the materials, which get created dynamically from our world information when the renderer gets created and initialized. We create a buffer for each material. We create information for our different meshes and combine them into vertices and indices. Yeah, we also have a starting point for handling different vertex offsets, so meaning that we create a local vector that just handles the meshes in a way where they all get combined into the same um, vertex and index buffer, but are segmented later on whenever we do create some rendering objects, meaning that the actual rendering objects will hold information about where to start and end different different meshes in terms of the vertex and index data. So yeah, we need to create a render object structure, and we've created some let's see, game object data structure. So our game object is just a struct. I know that in these times a lot of people do it object oriented and create a game object with different methods. as I've mentioned in a previous video, this will be a data-oriented design because I would like to support games that do have a lot of computations each frame. For instance, different physics computations and so forth. And the data-oriented design is simply way faster. It might not be faster by much when you combine object-oriented and data-oriented principles, but when there are a few objects, but once you get to a certain scale, it's just yeah, it's just faster, and it's easier to do further optimizations on data-oriented designs, which is also in part why it's faster, because the compiler can help you do optimizations. But yeah, you can also do them yourselves, and once you do alignment of the different data structures, you will also be able to handle the cache very efficiently. And should you do branch slash computations as well, as you should in data-oriented design, you will end up with a very fast algorithm for handling your game objects. So yeah, I'm not going to do our object-oriented design. We're going to do it just like basic structs, and I'm going to play around with what needs an identifier and what doesn't. For now, most of the objects have identifiers, and once they are sort of coupled to a specific object, they will also have an identifier that just points to the actual object. So we have our main game object here, which is something that I imagine is supposed to be somewhat renderable. We could tell the system that it's not renderable by just keeping these values, that it doesn't have a mesh or doesn't have a material. For now, these flags are supposed to tell the system whether to update the, for instance, object transform of the object or the material, or change the mesh or whatever. And eventually we will create a destroy flag to know whenever the object is supposed to be destroyed. Sort of like a garbage collection method of sorts. Excuse me. These objects aren't aligned in terms of memory layout, at least for now. But we do have render-specific data structures which are, whenever possible, aligned somewhat in memory. For instance, this is aligned to, or rather not aligned, but this first part could be aligned, and this is definitely alignable. But yeah, we will do optimizations of data structures later on. Anyway, I'm blabbering about. So the point is that whenever we create an actual game object, which I'm unsure if we do. Yeah, we do create a game object. Right now it doesn't do anything. We want it to be the mesh which has the ID of 0 and the material of 0. And I think this increments after assigning the value, so this gets an ID of 0. And in our renderer, during our pre-allocation of different informations or data structures, we get our vector of game objects and don't do anything with them right now. But we do create the actual object transforms, which get created down here, and which is hard-coded as a object in the actual rendering loop. So we want to create a data structure here internally. That holds the following information, and we can just look to our rendering loop because let's see if we move things around. If we move things around a bit, so these things. Let's see, semicolon missing. Oh, and a parenthesis. I moved that terribly. So these things are an actual object. I mean, this is general pipeline stuff. We have our, maybe we should move this up to our pipeline. This is just basic viewport information. Then we have our polygon pipeline information. Then we have our polygon vertex and index information, and its buffers. Then we have our pass data for drawing different objects in all pipelines. I'm actually unsure whether we need to create the pass data twice. Let's just test that, because right now we haven't changed anything. So since this is part of the second pipeline where we draw lines and not solid objects, if we disable binding the pass data after we bind to the new pipeline, we will see whether we need to bind the pass data. We don't. It stays bound, because we do not change the root signature. Eventually we might change the root signature, so we will just add a comment. Rebind the const pass data when we end up changing the root signature, because yeah, actually this pipeline doesn't use materials, so we do not need to set the materials. Yeah, it's fine. And perhaps we don't need to set the yeah, I'm unsure what happens when you bind another pipeline at another root signature, and if the root signature changes structure. I think, yeah. Let's see. Yeah. Be mindful of how root signatures or root signature bindings might overwrite root signature descriptors, root signature constant buffer views, to use the right terminology. from previous pipeline states. Yeah. So whenever we change the pipeline, which when the old pipeline might have another root signature, we want to make sure that perhaps the constant buffer that is bound to currently slot 0 stays bound, or we are mindful whenever it doesn't stay bound for whatever reason. We might not need the pass data. I find it highly unlikely that we do not need pass data in a specific pipeline, since it holds our real projection matrices and delta time and whatever we fill in that. So yeah. What happens if I'm unsure whether we can bind. No, we have to set the root signature first. Anyway, that's somewhat off topic. So let's see, this is an old draw call. So this is what we need in a so-called rendering object. So we need to get the transform, know where to find it in our internal buffer. We need a material index as well. So let's just create some comments here. Transform index, material index, and then when we draw the indexed instance, we need to know how many vertices are indexed for the mesh, and we need to know our offset into the index and vertex buffer. So that is basically what a draw call needs of information, since we bind the other information to our pipeline and thereby our shaders. So yeah, right here we need to fetch this information. Let's see. Let's just create new lines for that. And like that. So we would like to sorry if the gum is bothering you, just let me know. I'll stop chewing it. We want to create a data container, and as you can see, we have our different rendering structures. We have some system variables. We do definitely not need that one. And we have some test variables here. Some of them will eventually get upgraded into regular system variables, but for now, yeah, as you can see, it's mostly index buffers and their views, index and vertex buffers and their views. But yeah, we would like this is usually fetchable in other parts of the system. I think the following data structure is supposed to be only known for the renderer, since no other part of the system will ever use it. But yeah, for now these data structures are used in other places. We might do mirrors of them, maybe move one data structure here, or rather create a mirror of it in terms of, for instance, the lighting data, and then we could decouple this um, series of data structures from other parts of the code. For instance, this uses the renderer data structures, but it is also inside the renderer um, directory. Yeah, maybe I'll do that in the future. Anyway, I think that this structure is not supposed to be used anywhere else. We could move it to the actual renderer class. Mm. Uh, we could do that. Add it to the renderer so that it's not a type that appears anywhere outside the renderer. Yeah, we could do that just to avoid some confusion. Uh, let's see. And we want to just copy these comments. Um, let's just do the let's see, maybe we need just some information about the object ID. Yeah, I usually do these lowercase, but for some reason let's try that. Maybe we change it eventually. But I would like for the rendering item to be coupled to a game object whenever we know that the game object with ID whatever needs to be deleted. We would perhaps add the rendering item to a queue, and yeah, maybe do reference counting in terms of yeah, we might do a whole system to handle resources eventually. So yeah, maybe for now it's fine. Let's do a transform ID, and let's do a material ID, or rather an index. It's not an identifier. And then um, amount of indices and indice index offset, and of course vertex offset. Let's see, this should compile fine. Yeah. So it's basically just a object that holds our information, a lightweight structure. We would also like to create a vector of these. For now, our pipeline only has yeah, specific one specific vertex buffer and index buffer. So yeah, we would like to then create our some information here. We would like to create a render item, which we call item data, and let's just move it and create it in place. I'm unsure whether this actually calls perfect forwarding, but internally, does it? Yeah, it does. That's great. So we do not need to worry about that. So our game object. Let's see, holds the following information: an ID, meaning that our item data can get the ID. What can we else get? We can um, get our material and mesh ID. Since we know that these get created up here, we will know that whatever material has the first index, or rather gets created first, will correspond to this specific ID. Then we would like to store the transform. Oh, whoops, that's not correct. Material and the oh yeah, the transform. Now that is interesting. Mm, yeah, these the transform um hmm, should follow. Yeah, how do we want to do that? The transform, is it just supposed to follow the object ID? Since we probably would end up in a situation whenever we would create a renderable object, we will create a corresponding transform, but we might not create as many transforms as we create game objects, thereby the ID will have different values than the amount of transforms. Yeah, now that's a a problem of sorts. Yeah, maybe when we create the transforms, because but it does make us iterate through the different yeah, we could do an implementation where we iterate through all the rendering item data structures and find the one where the object transform ID, or rather the transform ID's internal object ID corresponds to whatever we create here. I think that's probably a better way to do it. And then store the internal value of whatever part of the series of buffers we want to assign to that. Yeah, that's the way of doing it. I'm not sure whether it's the right way to do it, but yeah, let's just do that. Const. No, it's not going to be const because we're going to change it. So data inside rendering items. If yeah, yeah, if the data object ID is equal to the corresponding object ID, we of course break out of this for loop, and we change the data transform index to I. Yeah, this is why these things are created at the same time. They're actually coupled. Yeah, so we don't assign the transform index on behalf of the yeah the actual game object. Anyway, so now we create the transform ID down below. Then we want to create mesh data. So let's see, we have meshes here, and this data structure contains whatever mesh information we need. So by calling meshes with the game object ID mesh specifier, we actually get the mesh, and we can, yeah, maybe meshes do not need an actual ID. We could just, yeah, maybe let's see, maybe we will end up deleting that. Yeah. But as you can see, we can grab our information here. So that means that when we want to create the amount of indices, which is the first parameter of our draw call, we just fetch whatever number of indices we need. Then we want to store our we have that, we have that, we have that, we have that eventually. So we need index and vertex offset. So let's start with the, I always prefer to actually start with the vertex offset, since it's let's see, let's just copy this vertex offset and then index offset. All right, the goal is to now sort of replace this drawn object with whatever we create outside the renderer in our application. This is supposed to be a so-called scene or world container. It's not supposed to be a part of the application, but for now we do not have a containing structure for handling preloading and so forth. We will eventually work on that whenever our application gets cluttered with different stuff. We also would like to sort of move these two parts, or rather change them a bit. Perhaps we have a world on create which will reference a singleton renderer on the whole application and pass that data in instead. Yeah, we will change that whenever we feel the need to do that. But for now, we just create our objects here, and we would like to test these pre-allocations. In terms of our actual renderer. So we would like to replace this with something that is dynamic. Of course, we could eventually do the same thing for our debug boxes pipeline. For now, we're just gonna do it for polygons, since we're most interested in drawing polygons automatically, debugging information. Yeah, whenever we find it cumbersome to add specific debug information, we will do the same thing in terms of doing opaque items, for instance, and then debug items and so forth. Yeah, maybe we want even different data structures, since some items will certainly not need more than maybe a transform and maybe some vertex and index buffer indices. But yeah, this can be a const auto reference to a item inside our rendering items. And we can just move this, and we know our item dot transform index is stored here, so we add that. We know our material index is stored in here, so we just add that. we know that the amount of indices to draw is stored in that. We know our base vertex location. First, okay, the last one is irrelevant, so we're talking about the last three zeros. So first we start off by the index location, actually the opposite of what I prefer. So let's store the index offset, or rather find the index offset, then the vertex offset, and the last parameter doesn't matter, since we're doing non-instance drawing. Alright, hopefully this draws the exact same box as before. And it does. So yeah, now we just need to try to create another object with another transform, and perhaps yeah, we also need to do cleanup in our resources. Yeah, we did that. Cleanup of resources on application close. There's also always something to do. Whoops. Let's see. So let's test it out. We would like to create another game object. Do we actually try to store other information? No, the dirty flag is not supposed to be used right now. Let's see. Yeah, maybe we would like to stop moving things and just create a copy anyway, even though it might be slower. Yeah, let's try that. I would also like to see what values get assigned. We would like for this to have a different material. Right now we have these materials. Let's just say we would like to have material number 3. We do not have any other meshes, so the mesh is supposed to be the same, and thereby we do like that. Let's see. Let's just do the same thing here, not move it anymore. Yeah. Did we ever use the object ID when we create our objects, or rather, so this, yeah, yeah, we do. I totally forgot what we just did. So let's say that we would like an object where we reset the transform, get identity matrix. Oh, the transform, of course. We reset the transform. We specify some new values. Of course, we need to change the object ID. Since we're using object number 2, we would like, okay, this is the first one. So to keep the identity matrix stuff here, we need to do like that. So this is the placement in the object space. Let's see. I only no. It's because so let's see. Right now this should place the object in the origin. Let's check that out. Of course, I asked it to show us. Yeah, it gets assigned to object ID number 2. What? Wait a minute. Well, that's not useful. Am I supposed to do like that? Oh yeah, okay. I misread the output. This might be right as well. Yeah, I looked at the wrong local. Of course, I need to check out whatever gets stored in this struct. So yeah, it works. So yeah, it's fine. Let's not debug that anymore. All right, we do have an error somewhere. Let's see. So somewhere in our application, a subscript is out of place, or rather, oh, we didn't add that as well. There we go. So we create an object now that has the transform and the specified material, which is great. The material is number 3, which has a diffuse diffuse color, or rather a diffuse albedo of 0, 0, and 1, meaning that it's 0 in red, 0 in green, but 100% in blue. Meaning that whatever ambient or non-directionally reflected light gets into the object, it reflects a blue light. It does have some properties in terms of whenever something is shining upon it, and whenever you get into a certain angle, what is reflected there. But it's as you can see, the same for every part of the color composition. So yeah, it won't affect the look much. It's not rough, it's not shiny. Yeah, and I think this value is supposed to express something that doesn't reflect a lot of specular lighting. Yeah, so that is it. Now we can start messing around with some more game objects. We have automatic static object preloading in our renderer. So now we can start building more objects in our game world. We can do it manually like this. We could start doing a scene world container. Yeah. We could do some logic to handle most of these things for us. The materials and lights are not that complicated. It's more the actual game object slash meshed objects that are something that we perhaps want to automate somewhat. Right now it's not that cumbersome. Yeah, we will do this sometime. Yeah, but we would like to create some game objects. And for that, we will use some Blender, and we will use royalty free resources. I would like to create yeah, we also need to talk a bit about game design, what to prototype. Yeah. Yeah, so there are all these different things to do, which we eventually will get around to. But yeah, I think that in terms of moving this project in an interesting direction, we will do perhaps first a short game design discussion, and then we will create some game objects for that, and we will start loading that into load that into a static world. And then we will probably start doing collision stuff, bounding boxes, in terms of being able to create non-static objects that can do something in our game world. Yeah, I think that's a fine outline. Then eventually, yeah, we need to move these things up here. Whenever we want to work on something that is fairly simple, we will do these bug fixes. This is optimization related. This is feature. Optimization related stuff can always be pushed further down the project roadmap. Yeah, one of our followers wanted to send me some stuff. Yeah, I'll move this up so I don't forget it. Yeah, picking. That is some more futures. Let's add a headline that is called something to the effect of let's move the textures up here. This is optimization related. This is optimization related. Some of this actually overlaps with platform generalizability, usage, or excuse me, some platform extensibility, meaning that we can do larger projects with these features implemented. This is optimization related as well. There we go. This is very, very late optimization. This is just, yeah. So we have these things in prioritized order now, because you could argue that bug fixes, yeah, maybe quality of life and features are somewhat interchangeable in terms of priority. Bug fixes and adjustments that I've noted are just minor tasks that probably don't need a separate headline. Anyway, um, I think this is a fine point to do some break, for me at least. Yeah, I think this is a roadmap that is fairly easy to sort of follow and get an actual idea of what to do next. So yeah, I'll be having a break. Maybe I will continue on later on today or later on during the following days. Yeah, hope you found any of this helpful or inspirational or something else that is positive. Yeah, feel free to comment, like, and subscribe, or even follow on Twitch. And if you want to help out the channel, always feel free to do that. There are different ways of doing that. Yeah, I'll be seeing you around, hopefully.